Okay, hello and welcome back. In the previous number of lectures, we looked at the terms and the background knowledge for hypothesis testing. And from now on, we are going to do hypothesis testing for specific scenarios. Now, the basic recipe will be the same for all the hypotheses that we test. So we will follow the same steps whenever we do a hypothesis test. The first step would be to state the null and alternative hypotheses. Then the second step is to state the significance level alpha. And by now, hopefully you know what the significance level or alpha value means. Then in step 3, we will collect our evidence. We will collect data in the form of a sample and calculate our test statistic from the sample data. Then in step 4, we will determine the rejection region, or we will calculate the p-value. Step 5, based on what we got in step 4, we will make a decision to either reject the null hypothesis or to not reject the null hypothesis. And then in step 6, we make a conclusion in terms of the original problem statement. Now, what you have here on the slide is a summary that you also had at the end of the chapter on estimation. And in this summary, we have the 3 population parameters, the mean, the variance, and the proportion. And we had the different assumptions and different sampling distributions. So we are going to make use of this same theory when we do hypothesis testing. Now, if you look at the very first row here, where our parameter is the population mean, if we sample from a normal population where the population variance sigma squared is known, then the test statistic is given there in the final column, and that test statistic follows the standard normal distribution. So when we do hypothesis testing, in this case, we will get our critical value from the standard normal table, or we will calculate our p-value from the standard normal distribution. I'm going to take you back to the example that we have been working with in the last few lectures. Okay, and if you look at this example, which you should be familiar with by now, you will see that we are interested here in the population mean, and that in this case the population standard deviation and therefore also the population variance is known. So if we go back to our table, if we go back to this table here, you can see that we are working with the very first scenario here. We are doing hypothesis testing with regards to the population mean mu, where the population variance is known. And if you go back to those lectures, you will remember when we did that example, we got our critical value from the standard normal distribution and also our p-value. So now we are going to move on to the next scenario, where we are again working with the population mean mu, but we are going to work with a small sample from a normal distribution where the population variance is unknown. And if that is the case, then our test statistic is given there in the final column, and you will see that we now substitute the population standard deviation sigma, we now substitute it with S, the sample standard deviation. And then our test statistic follows the t-distribution with n minus 1 degrees of freedom. N, remember, is the sample size. Okay, so let's look at an example. In this slide, we again summarize the hypothesis test. If we do an inference about a population mean, when the population standard deviation is unknown and n, our sample size, is small. And usually we say that n is small when n is less than 30. Now remember that our null hypothesis is always that the population mean is equal to some other value. We call that mu0. Then in the first column here, we have the three possible alternatives. The first one is where the mean is unequal to mu0, so that is our two-sided alternative, or we can have the right-sided or the left-sided alternative. The assumptions we have here are that the population variance is unknown, that our sample comes from a normal distribution, and that we are working with a small sample. Then our test statistic is given in the third column. It's the sample mean minus the value that we assume under the null hypothesis divided by S over square root n, where S is, remember, our sample standard deviation because our population standard deviation is unknown. And this now follows a t-distribution with n-1 degrees of freedom. Now, if our test statistic follows the t-distribution, it means that to find our critical values or the rejection region, we are going to make use of the t-tables. Okay, so I think the best would be to illustrate this with an example. Okay, so if we look at this example, the manufacturer of rechargeable electric shavers claims that the mean working time of the shavers between charges is more than 432 minutes. And then we have a random sample of 20 shavers and the results are given in minutes. Okay, so if we go back to our table here, our population variance is not known. And we are working with a small sample because our n is 20, it's less than 30. Now, it's not specifically given that our sample comes from a normal distribution, and there are different tests to test whether the data can be assumed to come from a normal distribution. In this lecture, we are not going to spend too much time on that. I think it would be sufficient at this stage just to set up a histogram of this 20 observations. So if you set up a histogram, you can see that the shape of this histogram does not deviate that much from the normal distribution, and therefore it is reasonable to assume for now that the assumption of normality is also met. And then we can calculate for this 20 observations, we can calculate the sample mean and we can calculate the sample standard deviation. So I'm quickly going to take you to Excel and we can do this and calculate the sample mean and the sample standard deviation in Excel. Okay, so here we have the time in between charges for these 20 electric shavers. And we can calculate the sample mean for these 20 shavers. So that is what I'm going to do here. I can use the function average in Excel and I select the 20 observations and that gives me the mean of 435,80. And then I can also calculate the sample standard deviation. And I choose the function stdev.s and the S stands for sample. So it's the sample standard deviation versus the .p would give you the population standard deviation. So I select those 20 observations and I get a sample standard deviation of 7.04. Okay, so now that is the information we have from our sample or the evidence. And now we can go forth and test our hypothesis. Now the first step when we do a hypothesis test, remember, is to state the null and the alternative hypothesis. Now the null hypothesis would be that the mean time is 432 minutes. And then the alternative is that it is longer than 432 minutes. And we get that from our original problem that the manufacturer claims that the mean working time of the shavers between charges is more than 432 minutes. So that is why we are testing the right-sided alternative. Then in the second step, we state the level of significance, our alpha value. Remember, the alpha is the probability to wrongly reject the null hypothesis, and we typically choose the alpha to be 5% or 1% or 10%. But 5% is a very common value for alpha. Then in the third step, we calculate our test statistic from the sample data. Now, our test statistic is this formula here. Our sample mean, which we calculated in Excel, is 435.8. And then we subtract from that the value of the mean when the null hypothesis is true. We divide it by S, the sample standard deviation, over the square root of n. Our sample size is 20. And then we get our t-value, or our test statistic value, of 2.4139. Then in step 4, we determine the rejection region. So the rejection region now comes from the t-distribution. And if this is my t-distribution, because I'm testing right-sided alternative, my critical t-value will be on the right side. And I want the area to the right to be equal to alpha, 0.05. So the area to the left must be equal to 0.95. And I'm working with n-1 degrees of freedom. So my n is 20, the sample size, minus 1 is then 19. So my rejection region will be the blue area and my acceptance region, the red area. Now to find this t-value, I go to my t-tables. And here I've got my t-tables. The area to the left is 0.95. My degrees of freedom is 19. So my critical value is this 1.729. So that is where my critical value comes from. That's the 1.729. And now if we go back to find our test statistic, 2.4139, then that 2.4139 lies to the right of my critical value. It falls in the rejection region. So in step 5, I make a decision. Since my test statistic value of 2.41 exceeds or lies in the rejection region, it's to the right of my critical value, I reject the null hypothesis. And then in step 6, we make our final conclusion. We say that there is enough evidence at the 5% level of significance to accept the manufacturer's claim that the mean working time of the shavers between charges is more than 432 minutes. In the next lecture, we will repeat step 4, where we make use of the p-value method.